had my first talk where I talked about what blockchain is and what promises the technology holds. But for those of you who couldn't make it, let's do a quick recap. So I mentioned that today, data, we cannot put value on digital data. This is because data can be infinitely copied and data is owned by someone. So when you can copy something infinite amount of time, you cannot assign value to it. Data today is not owned by us, but it's owned by big tech companies. So we don't have control over our data, and therefore we don't have data privacy. Data is not stored in a secured manner because they're stored in a centralized database that's owned by one entity, and they're prone to corruption, and the owner can always change the record. So I said that blockchain is a technology that solves this problem. So what is blockchain? Blockchain is a chain of blocks, like the name suggests, and each block contains a list of transaction records. This chain of blocks is maintained by hundreds of computers all around the world. Anyone can join whenever they want to, and they collectively maintain it, but nobody owns the blockchain. Now, because there are hundreds of computers maintaining the record of the blockchain, there needs to be a way for them to agree on what's true. And we do that with a consensus mechanism. Or we'll give them a couple of minutes. Hey, everyone. All right, let's continue. So now we have this decentralized computer, a decentralized database that allows data to be immutable. That's not owned by anyone. You cannot delete it, and you cannot change it. So because data is now immutable, you can assign value to a piece of data. Also, because data is not owned by anyone, we have control over your own data. And also, data is now stored in a secured manner. So I talked about some potential applications that can happen in the future and what's building right now that became possible because of blockchain technology. But what's crazy is that we still don't know what the killer application is for blockchain. And new possibilities, new opportunities are opening up every week with new innovation happening in the industry. So we know that blockchain is great. Everyone's caught up. Awesome. So let's say that you've decided to work with blockchain and you want to build something with blockchain. What's the next step? Right now, there are hundreds of blockchains out there, all claiming to be the best chain ever. This clicker is not working as I expected. It's ruining my joke. Anyways. Okay. So how do you decide what blockchain is the right decision for you? Hello, everyone. My name is Chris Kim. I'm a developer relations advocate for the Algorand Foundation, and my job is to help developers learn how to build on the Algorand blockchain. Algorand blockchain is a fast, secured, and decentralized layer 1 blockchain founded by Sylvia Macaulay, an MIT professor and a Turing Awards winner, and the creator of zero-knowledge proofs and verifiable random functions, which are both technologies that are widely used in the blockchain industry. So before we talk about the factors that you need to consider, let's first understand the current blockchain landscape. Ethereum was founded in 2015, and it was the first smart contract blockchain that allowed you to build application on the blockchain. Now, as the first mover, Ethereum reigned as the king of smart contract blockchains for the past few years. But as more people started building on the blockchain and more people started using it, people started to realize that Ethereum is a bit too slow and expensive for the average user. So, and the founder of Ethereum, Vitalik Buterin, said that to create a functioning blockchain, you need to sacrifice one of these key objectives: decentralization, scalability, and security. So you can't have it all. You can only have two. And that's called the blockchain trilemma. So Ethereum decided to sacrifice scalability, speed, to make sure that Ethereum is decentralized and secured. So the entire blockchain industry's objective now became, how do we make blockchain faster so that people like us can use it without paying insane transaction fees and have our transactions be executed within an acceptable time frame. So currently there are two directions that these blockchains are taking in general. I'm leaving out a lot of details. But one is to take a modular approach, to divide blockchains up into different chains that has certain tasks. There are other blockchains that are designed to just completely redesign a blockchain and do everything in one chain. So let's take a look at what modular blockchains do. There are four main tasks that a blockchain do. Execution, which is to execute transactions. Settlement, which is to settle transactions. Consensus, which is a mechanism of allowing these computers to agree on what's true. And data availability, using blockchain as a database that stores data and make them available to you. But they believe, people who build modular blockchains believe that one blockchain shouldn't handle all of these tasks. It's too much for one chain. So now they have specific blockchains doing specific tasks. So we have a blockchain that only does execution, executing transactions. And we have blockchains that only hold and validate data. So let's take a look at an example of how modular blockchains work. So we have blockchains like layer 2 blockchains, which act as an execution layer. So they execute transactions and they compress all of the transactions that happened into this one proof. It's like compressing an audio file into a zip file. Then they pass down that proof to the layer 1, which is a data availability layer. And in this example, they're using Ethereum as the layer 1 blockchain. The proof that's sent down from layer 2 is now validated on the Ethereum blockchain and stored on the Ethereum blockchain. So by taking this modular approach, we now are able to scale the blockchain without sacrificing decentralization or security because we're leveraging Ethereum's technology. So modular blockchains can scale with less sacrifices. Modular blockchains are also more flexible, and they can work with various layers depending on what they prioritize. And also because they're more flexible, it's easier to make them interoperable, meaning connecting different blockchains, allowing users to use applications from different chains and accessing liquidity that's on a different chain. But modular blockchains are not perfect. Modular blockchain is a relatively new idea, and it still hasn't been globally proven that this is a secure way of scaling a blockchain. So we're still in experimental stage. So if you decide to build with a modular blockchain, that's the risk that you have to take on. Modular blockchains also add complexity. If you want to build on a modular blockchain, now you have to understand all of the chains that are included in that tech stack. So that's multiple blockchains that you need to study, that you need to understand, and come to a conclusion that both of them are secured enough to use. Lastly, when you're building applications on these modular blockchains, it's harder to make them composable, meaning harder to integrate them into different applications. And that's because these applications may be using a different tech stack, a different modular blockchain. A different approach that we're taking to scale the blockchain is to completely redesign a layer 1 blockchain with different priorities. So how they scale it is by balancing the 3 key objectives within the blockchain trilemma. So I'm not mentioning any specific chains, but some chains may be sacrificing security just to increase scalability. Some chain may be sacrificing decentralization to maximize scalability. Or some chains, like Algorand, has figured out a way to balance out between these 3 key objectives and therefore solving the blockchain trilemma. But more on this later. So monolithic blockchains, everything is in one chain, so it's much easier to build on them. there's less thing that you need to study to understand. And as long as that blockchain is secured and you come to that conclusion, you're all ready to start building on that blockchain. Monolithic blockchains also have good composability because all of the applications that build on that blockchain know for a fact that all of the other applications are using the same technology. But this is not perfect either. Monolithic blockchains are completely redesigned blockchains that uses a different virtual machine than Ethereum. And currently, in the blockchain industry, EVM, which stands for Ethereum Virtual Machine, is the most widely used. Is that Siri? Oh my goodness. I apologize. Siri's just messing with me. Okay, where was I? EVM, yes. It's the most widely used virtual machine, and therefore, most of the developers and most of the developer tools are around the EVM. So when you have a blockchain that uses a different virtual machine, you can't leverage all of those tools and developers out there for you. But I'm not saying having a different virtual machine is bad, because EVM, while it's great, it still has its limitation. So if you want to achieve something more, if you want a faster virtual machine, a more efficient one, that's what these monolithic blockchains are doing. They're making a different virtual machine with different priorities. They're also harder to make interoperable because, again, they have a different virtual machine. And it's already hard enough to connect two different chains with the same virtual machine. So imagine how harder it will be to connect two different chains that have a different foundation. Lastly, these monolithic blockchains usually have their own unique smart contract language. So developers need to train themselves just to build on these chains. Whereas if you build on an EVM chain, if you learn Solidity, which is the most popular smart contract language on EVM, you can use that code on multiple chains. So based on what you prefer, based on what you prioritize, this is the first decision you have to make. Do I want to build on a modular blockchain or a monolithic blockchain? All right. Now let's talk about the factors that you need to consider to make that decision. And you're really asking, how well is this blockchain doing on these three key objectives? So let's start with decentralization. How decentralized is it? If I break that question down into two, it's basically asking, how easy is it for me to run a node? When I say node, I mean computers that maintain the blockchain. And how many of those nodes are there protecting the blockchain? Now, we've heard this term decentralization so many times that it almost has no meaning now. And people undermine decentralization so much. So some people think, we can just, we can sacrifice decentralization just a bit to make the blockchain faster. Well, I'm someone who strongly disagree with that statement. And here's why. I mentioned that these three things became possible because data on the blockchain is immutable. No one controls it, no one can delete it, and no one can change it. But now, let's say there's a centralized blockchain with 10 nodes protecting the blockchain. Now, when the blockchain is centralized, it's much easier for someone to come in, gain control of that network, because all they have to do is, if there are 10 nodes, they need to control 6 nodes to own that system. So think about it. Is it easier to control a blockchain that has 10 nodes or 1,000 computers? When someone gains control of these data, of this blockchain, now suddenly you lose all of the benefits that blockchain provides. Because if someone owns all of the data on the blockchain, they can change it, they can copy it. So you can no longer assign value to data. The data is no longer owned by you, but it's owned by that person. And your data is no longer secure. So decentralization is, in my opinion, essential for blockchain to be beneficial. So how decentralized is Algorand? we wanted to make it as easy as possible for people to run a node. So we created one-click nodes, allowing anyone to click a button and run a node. And to become eligible to participate in consensus, which is the job that all these nodes do, you need to have at least 0.01 algo, which is less than a cent at current market price. So it's very easy, it's very accessible for everyone. Now, Algorand isn't perfect either. So one of the biggest criticism that Algorand gets is that we have these things called relay nodes, which are specific types of nodes, and their job is to relay messages. They don't participate in consensus, so they don't have a say in what block gets added to the blockchain, but they relay the messages within the network so that we can achieve high speed. But the problem with relay nodes is, one, it's expensive to run them because you need a better computer to run this. And two, currently the Algorand blockchain defaults to a pre-selected list of relay nodes to relay these messages. So this is where people get angry. They're like, that's centralization. You know, the blockchain is only talking to these relay nodes that were selected by the foundation. And it is a valid criticism. But what people don't know is anyone can run a relay node. It's not, you don't have to go to the foundation, get permission to run a relay node. And you can configure your node to only talk to these customized relay nodes and circumvent the pre-selected relay nodes. Yet, it's still a valid criticism. So Algorand is in discussion of implementing a peer-to-peer gossip protocol, completely circumventing these relay nodes and making them optional. So if you want to use the relay nodes, you can, but you can also not use relay nodes at all and just use a peer-to-peer gossip protocol and have your transactions be executed. So if you're interested, I recommend that you go to the Algorand GitHub and check out the discussions that's happening right now. All right, next question. How secure is the blockchain? When I say security, I mean that all the data that's on the blockchain is permanent, authentic, and is available to everyone 24/7. That's what a good security means. Now, some blockchains out there, in order to make the blockchains faster, they're sacrificing security. That means their chains occasionally go down, making the data not available to everyone 24/7. And some people might say, that's okay, you know, I don't need my data to be available 24/7. But if you're building a financial application that relies on data being available all the time, then that's a detrimental case. So this is why I'm telling you, you need to spend time looking into these blockchains, see what they do well and what they aren't so good at. So how secure is Algorand? Algorand's mainnet launched in 2019, and for over 3 years, the Algorand blockchain has never gone down. And we are committed to this because we know how important security is for the blockchain. Algorand is also the first blockchain to make all of the data on the blockchain post-quantum secured, meaning data is now safe from quantum computing. Now, the blockchain industry is scared of quantum computing because when quantum computers become a reality, most of the blockchains out there, they're going to break. But Algorand is future-proof, and we're ready for that future. All right, next question you want to be asking is how fast is the blockchain? And to answer this question, you want to be looking at these 3 metrics: TPS, block time, and time to finality. TPS stands for transactions per second. So it means how many transactions can this blockchain execute per second. Block time is the time for your transaction to be added to a block and for that block to be added to the blockchain. Now, time to finality is the most misunderstood thing in this industry, and a lot of people have different ways of calling this, but I'm going to say time to finality, and I'm going to define it as the time after the block is added to the blockchain, the time for that block to be completely finalized. Now, you would assume that when a block is added to the blockchain, that block is final, meaning all the transactions in that block is immutable. Well, that really isn't the case for a lot of the blockchains out there. But I'll talk about this later, more on later slides. So how fast is Algorand? Currently, Algorand can handle about 10,000 transactions per second. And to put that into perspective, Visa currently handles about 1,700 transactions per second on average. So what that means is Algorand is ready for global usage. Algorand currently has a block time of 3.4 seconds. So when you send a transaction, that transaction is being added to the blockchain in 3.4 seconds. Now, what's unique about Algorand is that time to finality on Algorand is 0 seconds. So it's instantly final. Now let's touch on that instant finality bit a little bit more. Now, when a block is added to the blockchain, I know I'm getting a bit technical, I apologize, but depending on what consensus protocol the blockchain uses, there's a chance for 2 blocks to be added to the blockchain at the same time. Now we call this situation forking of a blockchain. Now when this happens, both of those blockchains are true because they've been validated and they've been accepted to the blockchain. But now we have 2 different records. We can't have that. So what they do is the network of computers that maintains the blockchain, they build on both chains and they make a decision on what chain is true. And as time goes by, there will be a clear winner with a longer chain. Now when that becomes apparent, the shorter chain is completely ignored and all of the transactions that were included in that shorter chain is canceled. So what does this mean? It means if you build on a blockchain that doesn't have instant finality, you as a business owner, you as a CEO, you have to consider this uncertainty. So you have 2 options. You can, one, just take the risk, say that the transaction's final, and take on the risk that it may be canceled in the future. Or you can play it safe and wait 6 or 7 blocks to go by to be certain that your transaction is final. Now, a lot of these chains recommend for you to wait 6 or 7 blocks because that's the amount of time usually to be certain that, okay, this is definitely the true blockchain. So to give you an example, currently Ethereum has a block time of 15 seconds. So that's 15 seconds for your transaction to be added to the blockchain. But because they're recommending that you wait 6 or 7 blocks, even when Ethereum is not congested, so it's the fastest you can be, you're gonna have to wait at least 1.5 minutes for that transaction to be executed. So imagine going to a coffee shop, you buy a cup of coffee, and you pay an ETH, and you stand around for a minute and minute and a half, just waiting for that transaction to go through. It's not ideal. Well, on Algorand, because we have instant finality, it will always be around 3.4 seconds. And that's the power of Algorand, and it's one of the most unique and powerful features that a lot of people miss out on. Next question, how cheap is it to send a transaction on this blockchain? Now, before we answer that, why do we have to pay for transactions in the first place? You know, it seems ridiculous, isn't it? Well, there are 3 reasons. One is to prevent transaction spamming. Now, if someone decides to spam the blockchain, send 1 million transactions at once, now the blockchain is going to be so busy handling all those transactions that they're not going to be able to handle everybody else's transactions. So what that causes is it causes the blockchain to crash. So to prevent that, now you have to pay for all of these transactions. So to send 1 million transactions now is going to be ridiculously expensive. Blockchain also has scarce resources, and this kind of ties along with the first point. Everybody has to share this limited resources, and that's why it's so important that the blockchain is fast, because when the blockchain is faster, you have more resources that you can share with among the people. And lastly, some blockchains use the transaction fees that are collected to pay node runners. Now, it's not easy to run a node for these blockchains. Excuse me. You have to have a computer that's strong enough to hold the entire record of the blockchain. You need to have that computer running 24/7, and which constantly uses electricity, and therefore it costs money. So these blockchains use the collected transaction fees to reward them for their work. So why does cheap transaction fee matter? Well, one is highly related to blockchain speed. If the blockchain is faster, there's less chance of that blockchain being congested, therefore spiking up that transaction fee. It's also important because it's tied directly to your operation cost. So if you're building a business on the blockchain, you're going to be transacting with the blockchain constantly. And every single time you send a transaction, you're paying for that transaction. So if the transaction fee is high, that directly ties to high operation cost. Even worse, if the transaction fee is unstable, volatile, you're not going to be able to predict how much money you're going to use to run your business, which is a nightmare for CEOs. Cheap transaction fees are also important for users because they're going to have to pay for transaction fees as well to use these decentralized applications. So it doesn't make sense for you to pay $50, $100 to send $10. So how cheap is it on Algorand? Algorand has a fixed transaction fee of 0.001 algo, and at current market price, that is also less than a cent. Now, what's great about Algorand is that this fixed transaction fee is for all types of transactions, from a simple payment transaction to a complicated, expensive smart contract execution application call. All these transactions cost 0.001 algo. So to summarize, basically you're just determining how well does it do on the blockchain trilemma. But according to Vitalik Buterin, the founder of Ethereum, we can't have it all. But that's not true, because Algorand has solved the blockchain trilemma. So how does Algorand excel in all three of these key objectives? And this is the perfect time to ask, what is the consensus protocol on this blockchain? Consensus protocol is a method of how the nodes reach an agreement on what new block to add to the blockchain. And the two most popular consensus protocols are proof of work and proof of stake. Proof of work is a method where the block validators are decided based on how much computing power you have. So if you have more GPU, stronger computers, you're more likely to be selected as the next block proposer. This is why we see giant Bitcoin mining farms out there, because they want to be running thousands of GPUs to beat the competition. Proof of stake depends on how much crypto you stake to the blockchain. So the more money you put in, the more likely you'll be selected as the next block proposer. The consensus protocol is important because this is the process that validates the transactions. If this consensus protocol doesn't work properly, we're going to be seeing fake transactions, bad transactions being recorded on the blockchain. And we don't want that. Because what makes blockchain special is the fact that we can trust the record on the blockchain. So if the consensus protocol is robust, it will validate the transactions properly, therefore securing the blockchain, and therefore creating trust in users. So if you trust the blockchain, you no longer need to trust this anonymous entity that you're dealing with. So if you are trying to buy, water from Amazon, a decentralized Amazon built on blockchain, you don't need to trust who the seller is. You trust that the blockchain will handle that transaction fairly for you. Now, this is the big question. When you have a lot of computers maintaining the blockchain, that means during your consensus process, there are more computers that need to communicate and come to an agreement. And when there are more people, it takes much longer to reach an agreement. Therefore, a decentralized blockchain should be slow. And on the contrary, if there aren't a lot of people that you need to communicate with, that blockchain is going to be fast. But how does Algorand achieve both decentralization and scalability? Algorand uses a unique consensus protocol called the pure proof of stake. And this was created by our founder, Sylvia McCauley. And he created this because he believed that the most popular proof of stake protocol, which is delegated proof of stake, he believed that it was too centralized. So the way delegated proof of stake works is that you have a small group of computers that are directly participating in consensus. And the rest of the network, they just delegate their tokens to the representatives, just like how we vote to elect a president or a government person to speak in behalf of us. But the problem with this system is that these small groups of people are already known to the public. So when people know who will be participating in consensus, there's a chance of some bad person to attack these well-known computers or bribe them even, trying to cheat the system. So Sylvia Macaulay didn't like that, and he wanted everyone in the network to participate. And Algorand achieved this with randomness, hence the name Algorand, algorithm and random. Pure proof of stake allows everyone in the network to participate. And to be eligible to be selected to participate in consensus, you only need to hold 0.01 algo. So it's very easy and very accessible. But remember I said, when there's more people participating in consensus, it slows down the process. Well, in Algorand, the actual consensus process is done by a small group of people. And that small group of people are randomly selected using this technology called VRF, which is an invention by Sylvia Macaulay to come up with a truly random value in the digital world. So by randomly selecting these small committee every single round, you're allowing everyone to have a chance to participate in consensus, but the actual consensus is being done by a small group of people, therefore allowing both decentralization and scalability. So far, we've talked about what makes a great blockchain, but that's not the end of the story. Even if it's the best blockchain out there, if it's hard to build on it, yeah, you're gonna have a hard time building a successful business on there. So you wanna be looking out for these three things. It's not a comprehensive list, but it's a good starting point. You wanna first check what smart contract language does that blockchain use? Is it hard to learn? Is it popular among developers? Are there a lot of good documentation on it? If the smart contract language is hard to learn, then it's going to take you much longer and more it's going to cost you a lot of money to hire a developer who knows this language, and it will be a problem for you. You also don't want to be looking if the blockchain has a lot of developer tools, because you're going to need the help you can get, the most help you can get, because building a blockchain-based application is not easy. So having a lot of developer tools that you can just use right out of the box to build your application is crucial. Lastly, educational content. You're going to be learning something new if you decide to build on the blockchain. And if there aren't good documentation, good tutorials, an interactive live developer community, or a good dev support, you're going to have a hard time. Now, if you're interested on how easy it is to build on the Algorand blockchain, I recommend that you come to this room tomorrow at 11:30 a.m. to hear about what it's like to build on Algorand. Now I sound like a PR person. But that's the end of the presentation. I really hope that you don't skip this process, and a lot of projects do. You know, we see projects that just go with the most popular chain, or go with the blockchain they first saw, or just go with the blockchain that pays them the most. But what they realize is during development, they realize that this blockchain is not well suited for their use case. Then they try to migrate their entire project to a new blockchain during development, but in the blockchain world, that's almost as hard as starting a completely new project, because these blockchains are completely different softwares, differently built from the ground up. So you won't be able to reuse your code on a different blockchain. So I really hope that after this presentation, it has encouraged you to do the research, really understand what these blockchains do and how they're designed, and make the best decision for your business. Thank you.